On December 3, 2023, a powerful shockwave from an X-class solar flare engulfed Earth. The SOHO spacecraft recorded a massive ejection of fiery plasma traveling at an astonishing speed of over 2,000 kilometers per second. Fortunately, this eruption occurred on the far side of the Sun, sparing our planet from catastrophe. However, scientists are growing increasingly concerned about the Sun's unprecedented activity. In the first 3 months of 2023 alone, 7 X-class flares were recorded, the same number observed in all of the previous year. Experts attribute this surge in solar activity to the Sun nearing the peak of its 11-year cycle, which they warn could be one of the most intense in history. As a result, Earth may not be able to avoid destructive solar shocks. Since ancient times, people have observed dark sunspots, but it wasn't until 1852 that Swiss astronomer Rudolf Wolf identified their cyclic pattern. Sunspot activity increases for 5 to 6 years before reaching a peak, then declines for the same period. Each cycle also involves a complete reversal of the Sun's magnetic poles, which leads to deformations that generate solar flares and coronal mass ejections, or CMEs. One of the most significant solar events in history occurred on September 1, 1859. British astronomer Richard Carrington observed a sudden, intense flash of light on the Sun that lasted 5 minutes. 18 hours later, Earth experienced a geomagnetic storm of unprecedented magnitude. The skies lit up with auroras so bright that night became day, even at the equator. Telegraph systems across Europe and North America sparked, caught fire, and transmitted messages without power due to the excess electricity in the air. Carrington was the first to establish a link between solar flares and geomagnetic disturbances on Earth. The Sun had been emitting smaller flares for days before the event, which created a clear pathway for the plasma to travel straight to Earth in record time. Normally, such ejections take 3 to 4 days to reach our planet, but in this case, the charged particles arrived in just a few hours, triggering a devastating shockwave. In today's world, where electricity is as vital as air, the consequences of a similar event would be catastrophic. The financial losses would be in the trillions, and restoring infrastructure could take decades. But what if we prepared for life without electricity? Could stocking up on generators for a year make a difference? To answer that, we need to understand how solar flares impact our planet. Earth's magnetic field and atmosphere provide a crucial defense against cosmic radiation, but powerful solar eruptions can still cause severe damage. High-energy bursts can ignite power lines, as seen in 1972, when more than 60 underwater mines off the coast of Vietnam mysteriously exploded due to a geomagnetic storm affecting their magnetic fuses. Beyond disrupting technology, solar flares might also trigger geological events. Researchers at the National Institute of Geophysics and Volcanology in Rome analyzed 20 years of seismic activity alongside solar data and found a possible link between solar flares and earthquakes exceeding magnitude 5.6. The theory suggests that positively charged plasma particles interacting with Earth's magnetic field generate electromagnetic currents that deform the planet's crust, destabilizing fault lines and potentially causing quakes and tsunamis. A study by physicist Hugh Hudson in 2021 estimated that the Carrington flare's energy was equivalent to 10 billion megaton nuclear bombs. Even more alarming, flares 10 times stronger are expected every 3,000 years, while events 100 times stronger could occur every 6,000 years. When the next colossal solar storm hits, its charged particles will reach Earth in less than a day, overwhelming electrical grids and causing power surges that will cripple infrastructure. Power plants and substations will fail, igniting widespread fires. Emergency response will be paralyzed, heating and cooling systems will shut down, and access to clean water will be severely compromised. Hospitals will lose life support capabilities and chaos will ensue. Given these risks, is there an alternative to relying on the Sun? Scientists have identified around 17,000 potentially habitable stars within 1,000 light-years of Earth through the SETI project. These stars, known as HAB stars, meet strict criteria. They must be at least 3 billion years old, have stable temperatures around 5,800 Kelvin, and exhibit minimal brightness fluctuations. However, even if we found a perfect solar twin, the logistics of reaching and colonizing another planet remain insurmountable for now. While searching for a new home, scientists have also identified celestial objects that pose grave dangers. In 2014, NASA's New Star telescope discovered M82X2, an X-ray pulsar emitting energy equivalent to 100 million suns. Such stars are compact yet powerful, with magnetic fields so intense that they emit deadly radiation across space. Even more extreme are quasars, which are supermassive black holes at the centers of young galaxies. They consume nearby matter, releasing radiation so intense that it disrupts communications, causes genetic mutations, and ultimately destroys life. If deadly celestial objects make survival impossible, could we exist near an alternative sun? Our sun is classified as a yellow dwarf, yet much larger stars exist. Betelgeuse, a red supergiant, is 105,000 times brighter than the sun and 1,500 times larger. However, its unstable pulsations make it an unlikely candidate for sustaining life. On the opposite end of the spectrum is Rigel, a blue-white supergiant in the Orion constellation. It burns at 11,000 Kelvin and radiates 40,000 times more energy than the sun, producing lethal ultraviolet and X-ray emissions that would instantly incinerate any planet in its habitable zone. One of the most promising alternative systems is TRAPPIST-1, which hosts 7 Earth-like planets. 3 of them orbit within the habitable zone, where liquid water could exist. However, the system's ultra-cold dwarf star emits mostly infrared light, making natural illumination on these planets dim and unfamiliar to human eyes. Their short orbital periods mean that a year lasts just days, and they are tidally locked, always showing the same face to their star. If a second star were introduced to balance the system, it could provide more stable conditions. What if Earth had 2 suns? Binary star systems are common, with planets often orbiting 2 or even 3 stars. However, maintaining a stable climate in such a system is challenging. If both stars are dim, the planet would be a frozen wasteland. If too bright, it would be an uninhabitable desert. The ideal scenario would require both stars to be of equal mass and close enough to each other to stabilize planetary orbits. Otherwise, Earth would either be flung into space or drawn too close to one of the stars, leading to destruction. Despite all these possibilities, our sun remains both our greatest provider and our greatest threat. It once spun 10 times faster than today, its powerful stellar winds stripping Mars of its atmosphere and magnetic field. Eventually, its outbursts will directly threaten Earth. When that day comes, the best defense will be preparation. Stocking up on food, water, and generators, and seeking refuge in a safe location free from earthquakes, tsunamis, and hurricanes. Giant sequoias, which have survived for over 200 million years, remain impervious to fire and decay. These ancient trees have withstood asteroid impacts, acid rain, and ice ages. When the next great solar storm arrives, meet me beneath the branches of the President, one of the world's oldest sequoias, standing tall for over 3,000 years. Until then, where do you think the safest place on Earth would be?